All right, we're going to do our third and final page of homework on section 4.3. Let's look on page 382 in our textbooks. Let's start with number 50. Number 50 says tangent of 1, 2, 3, 4, 5, 6, 7 pi minus tangent, 7, 6, 5, minus tangent, 7, 6, 5, 4, 3, 2, 1 pi. So subtract those and get something. And it says, using the period of the function, and basically what that means is that these functions will repeat themselves. And they'll repeat themselves and repeat themselves. And let me go ahead and note something here. The function and period. And the period is just how long it takes for it to repeat itself, like our periods in school. Every first period, second period, that's how long it takes for that class cycle to repeat itself. Okay, so we have sine, cosine, and tangent. For sine, 2 pi. After you go all the way around the unit circle, it starts to repeat itself. Cosine is also 2 pi. And tangent is unique. Tangent is just pi. And if we look at the unit circle, we can kind of see why. Basically, because for tangent, it's the opposite over the adjacent. It is the y coordinate over the x. And just to do one example here, if I take the y over the x for here or here, I get the same thing, because that's a positive divided by a positive, the same numbers, and that's a negative divided by a negative, which comes out to a positive. So because the points opposite the unit circle are always like that, tangent repeats itself just after pi. Okay, so go ahead and try number 50 using that fact. Pause. Okay, we're back. If tangent repeats itself after pi radians, well, like for example, the tangent of 2 pi is going to equal the tangent of 3 pi, right? Because it just goes pi more. Tangent repeats itself after pi. So really, any multiple of pi will be the same thing. So tangent of 1, 2, 3, 4, 5, 6, 7 pi minus tangent 7, 6, 5, 4, 3, 2, 1 pi. Okay, well, this is going to be the same as tangent of 0 pi. Right, tangent of 0 pi. Or just tangent of 0. And the same thing here. This is just some multiple of pi. This would be the same thing as tangent 0 pi. And without even having to think about what that is, anything minus itself is 0. So number 50 gives you, whoops, 0. Sorry about that. Okay, let's look at one more like this, number 52. This will be the last one we do together. Number 52, cosine of 5, oh my goodness, 7 fives. 7 fives pi over 2. What is the cosine of that number? Go ahead. Okay, to give me some idea of what this is going to be, I'm actually going to use my calculator to try to get the pattern here, and then, but I'm certainly not going to hit enter that many times. We need to find some kind of a shortcut to get us down to where we need to be. So 1, 2, 3, 4, 5, 6, 7 over 2, and I can subtract 2 from this number. I can subtract 2 pi, because the period of cosine is 2 pi. It'll repeat itself, and that will give me an equivalent fraction. So I can just keep doing this. Okay, and what's one thing that I notice? It is like, oops, hang on, math. Oh, it won't make it into a fraction for me. Let me see here, minus 2. Let's go ahead. And if I keep doing this, you'll notice that this is always just an odd number and a half. An odd number and a half. So if I kept going, I will get to 1.5. That will be the very last one I got to before it became negative. You can see it's just another odd number, 0.5. So this is eventually going to equal 1 and 1.5 pi. And of course, we usually never write it this way. This is 3/2 pi. So this is equal to the cosine of 3/2 pi. Okay, well I can do that one. Let me look at my unit circle. 3/2 3 over 2 pi. Oh, 3/2 pi. Goodness gracious. That's a that's one of those 90 degrees angles. Yes. Okay, I was looking at my unit circle and I was confused. I was like, where's 3/2 pi? Of course. Silly me. So 3 pi over 2. There we go. 0 or 2 pi. Okay, so what's cosine of 3 pi over 2? Well, let's draw that shady looking 0, 90, 90 right triangle. There we go. And cosine is adjacent over hypotenuse. So 0 over 1 is 0. So number 55, the cosine of that angle is 0. I'm sorry, number 52. I forget. Did I say something else? I don't know. Try some problems for me, please. 49 through 59 odd. With an exclamation point. That doesn't mean factorial. That just means I'm excited.